Good afternoon, ladies and gentlemen. We're delighted to have Craig Mundy with us today, giving the CSAIL Dertuzzo's distinguished lecture.
So let's go ahead and put your glasses on if you haven't already, and because this part will actually be in 3D. So as I approach the sensor, it recognizes I'm here and brings up, if you will, quote, my desktop. And in this environment, I'm going to use gestures to control that. And so the first thing I'll do is essentially raise up the user interface. And in this environment, I can actually use my hand to scroll back and forth, to select in different basic areas. And the first thing I want to do is stop in this information category. So when I stop here, it says, here's a reminder that my aunt has a birthday and I wanted to buy her a gift. So I'll say, computer, show me Aunt Sophie's wish list. So in this case, Aunt Sophie's some eccentric lady, and the way she has expressed her wish list is she places objects into this virtual room that is of her choosing, and people that she's familiar with can come here and see what it is she might like to have. But this isn't particularly useful for me. There's certain things in here I might be able to buy and others that I probably wouldn't do. So to make it easier to shop, I'll ask computer, organize this in my preferred way for shopping. So it takes all the items, clusters them together, recognizes certain categories like shoes I would be more appropriate to give a gift card for, categorizes them, and then sort of places them on these virtual shelves for me to look at. So maybe I could reach out and pick up or look at some of the items here, like the lunch boxes. Say, well, that's not exactly what I had in mind. So I'll go up to the next shelf and pick up this pasta maker and bring it forward and examine it. Here it gives me the metadata for it. I can try to determine, is this thing too complicated for my aunt? So I'll basically use a gesture to essentially explode it into its pieces and say, oh, that looks pretty hard for her to maintain. But I could essentially turn it around and look at it in different ways. And I'll say, okay, that I think is too hard. So I'm going to push that one back onto the shelf. And I'll go over and pick up the green one. It looks a little simpler. And bring it in. That looks a little easier. Let's expand that thing into piece parts. Looks a lot simpler. I can essentially turn it around, look at it from different angles, push it back and look at it straight on. And I'll say, yeah, okay, that's the one I want. So I'll gesture this and put it into the box and buy it. So computer, I'm done shopping. So in this environment, I've got a more natural way of interacting with things. I'll come back now, and we've been doing some experimentation around what it might be like to develop not just traditional video games, but where gaming and essentially large-scale multiplayer gaming may intersect in the future with a genre of television. And so here let me select the entertainment category and show you a video that's been put together for what it might be like to have one of these player participating TV series. So computer, run the 2080 trailer.
My name is Nina, and I have broken the future. The world I knew is gone, and in its place, two disparate futures, intrinsically linked but unable to coexist. Now agents from both futures fight in the past for survival of their worlds, and I'm caught in the middle.
You will take control of the node.
The spy from the 2080s.
Feature films and mobile gaming events, weekly episodes, mission assignments, and mobile games.
So we think people will start to produce environments like this, and we'll show you what maybe one of the missions might be like here that you might play in. So here's actually a 3D model, a virtual space where the players in the game can actually come together. So while they're not physically present, they can be telepresent with each other. They can converse and exchange items and ideas. So I'll start walking around in this environment a little bit. So there's different people here. Today, despite all the progress we've made in computing capability and graphics, it turns out trying to do this demo in real time, we are actually computer limited. We need a lot more compute power than we currently can reasonably put together. So here I'm going to go approach my friends that I've been playing with and talk to them a little bit about the game.
Hey, finally, you made it.
Yeah, it's good to see you.
Hey, check it out. We found this piece, and it's just like this other one I found a few episodes ago.
Wait, which one was that?
Oh, well, it was the one where she drew that marker on the garden wall. Ring a bell? Okay, well, here, let me just show you. Okay, so anyway, I went to that wall, and I found one just like the one we found today.
Yeah, so we're thinking that they're probably part of a set. I don't know, maybe there's more around here if we looked.
Throw me that one that you got there. So let me turn this around, and maybe this is a clue that we can essentially decode. So let me spin it around and try different orientations for this environment, and see if it starts to come into some alignment. So we find out, well, actually, this does appear to be a picture if you look at it right, and in fact, it's a video.
Very cool. Hey, wait a second, is that a secret scene?
Hey, they promised it'd be in one of the mini games. Maybe that's where they show how Grid 47
I
got
can
screwed
knock
up.
it off axis a
Give me-
little
let me
bit.
see.
You realize it's actually a lot of composite little pieces of video that only appear as a clue if you look at them all in the right direction. Here, let me throw it back to you guys. And you go ahead and watch it. Okay, I got to go back to work here.
Oh, okay, right. Well, go ahead.
Sorry I'm
We'll talk
bothering
to
you.
later.
See you later.
Okay, sorry to bother you. So in this environment, we see a lot of opportunity for people to get creative. And whether the games and TV series will actually emerge this way, it's hard to tell. But at least the technological basis of doing that is clearly going to be possible. So let me explain to you a little bit about how this sensing environment works and how we've been able to get this to be relatively economical. So if you bring up the output from the sensor over here. So what you actually see here is sort of a debugging image. The sensor's sort of behind me. If I face it and make any kind of movement, you can see that what it's doing is building a skeletal model of me. In this case, it builds a model of the 42 major joints in the human skeleton. It does it at 30 hertz, and it'll do it for 4 people at a time. And it does that seeing essentially in the dark, because this part of the imaging is done using infrared for illumination and timing. And so even in a dimly lit environment or a room where you're watching television, you can see these things. Many people thought, well, how hard can this be? You just have a bunch of cameras and look at people. But it turns out to make this really work is much, much more difficult than one would imagine. And there were a lot of problems. So, for example, different parts of the body are occluded, as a function of whether I'm facing the camera or not facing the camera. So that and if there were multiple people in here, as they pass in front of one another, there's a momentary occlusion of the other player. You really can't allow that to happen in a logical sense if you don't want to disrupt the gameplay, particularly in a multiplayer environment. And so a lot of work was done to basically deal with this as a statistical problem and a modeling constraint problem, and not simply a image recognition or machine vision problem. And so as you move around in this environment, as you get closer to the camera, you can see the sort of the heat map changes, which is showing what the distance is. And each of these things can then be interpreted by the application. The image on the left is the RGB regular video camera, and you can see there's a big spotlight back there, and part of the audience is visible in front of me. But taken together, each of these things can then be mapped into a set of commands that relate to whatever the application is that the person wants to do. And so when I showed this to somebody a few days ago, they said, oh, well, does this mean that I have to learn which gestures map to the Xbox controller buttons? And that's a completely wrong way to think about it. Here what we're trying to do is create a genre of games where there is no notion that you're having to think about mapping what you would naturally do into a set of discrete actions, but rather you just operate quite naturally on it. And so when we have now built the new games with that model, you find that people who never played a video game before, perhaps even never had any interest in thinking they wanted to play a video game, are able to immediately, literally in seconds, get into these things and start to operate them, because in fact it's no different than operating in the natural world that they already understand. So to give you an idea of sort of an alternative mapping, what I've done is built a room and put a model in it. So when I step closer to this thing, it's going to actually take that model, and as I get close enough, it's just going to use that as a cue to pick it up. Now the green dots here are essentially mapping my hands, and it's measuring not only where their position is sort of in this plane, but actually in space. So when I actually put them in front of me, they turn red, and at that point they're active in terms of manipulating the model. So if I pull them back, my hands are not active. So if I put one in, I can essentially spin this model around and do different things to it. If I actually put both hands in at this level, sort of about my head, the thing basically will essentially expand it into its piece parts. And then I can essentially manipulate that, turn it around and look at it. Sort of at waist high, it basically becomes a zoom control. And you can see that I'm making fairly small physical gestures, fairly smooth, and it's essentially tracking the modeling in real time. Now, many of you probably went to the movies and saw something like Avatar in 3D. And the process by which those things are created has a huge amount of post-processing involved. And at the end of the day, they stream a linear set of bits through these projectors that produce the polarized output, and the glasses allow each eye to see a different image. Part of the magic in this particular presentation, which has not been done certainly very often anywhere in a theatrical kind of presentation, is to do this with real-time computed geometry. Now, to do this, we've got the Xbox doing the sensing, feeding the output stream of my skeletal positions as input to a PC program, which is actually rendering the model. So we got dual 4-core Xeon processors, so essentially the biggest PC you can do, the highest end NVIDIA graphics card you can use. And this, in 3D real-time, is limited to about the 300 parts that we've got in there in this essentially very simple environment, a single light source, no real walls, not a lot of texturing. And so while many people today talk about how far we've come with computing and do we need any more, when you start to decide you want to create really high-resolution models, you want to create them in real time and operate them in real time, and certainly when you start to think about HD quality movies or games or multi-party games and telepresence, in a sense it would be, we'd be very happy to have another couple decimal orders of magnitude in terms of computing and graphics performance in order to be able to do this at the frame rates that would be optimal and with the resolution and amount of detail in the scene that we would really like to have. So we're pretty optimistic. So when I actually step far enough away, the thing will put the bike back together and put it back on the floor. So this is just an example of a small team who were able to take the basic technology of the gesturing system and then map it into an application of their choice. So we get pretty enthused. You can take your glasses off. That's sort of the end of the 3D part.